The document class provides an easy way for us to store formatted information in an object. In the program in front of us, we've read in information from a cars.xml file into our Java document object. Here's what that file looks like. The root node of this file is the cars node. And contained within this node are two owners, Billy and Jane, each of which have a number of cars within them. The information stored within these car elements is mirrored by the information that can be stored by this Java class we have. Our goal in this video is going to be to take the car information from cars.xml for only a specific owner, in this case, Jane, and store this information in our custom car class so that we can utilize the car class's toString override to print all of Jane's cars to our console in a nicely formatted manner. With the code we have already set up, our document object mirrors the information stored in cars.xml in the same format. So we simply need to figure out how to ask this document the question, what cars does Jane own? In order to figure out how to write our code, we're going to need to know a little bit of XML terminology. We're going to be dealing with the terms element and node throughout this video. In XML, an element is an entity that has a start and end tag, and that element also contains all of the information within it. This highlighted piece of our XML document is the element owner with attribute name equals Jane. When our document object returns us information, though, it will often return the information in terms of nodes. Nodes are the building blocks of XML documents, and we can almost think of it as an inheritance relationship, where all elements are nodes, but not all nodes are elements. Nodes can be much simpler and smaller than an entire XML element. So, in the pursuit of finding all the cars owned by Jane, let's see what functionality our XML document provides for us right off the bat. If we take a look at code completion to quickly scan through our list of methods we can call from our document, we're going to see this method getDocumentElement, which returns an element for us. This is probably a good way to start. This method returns the top level element in our XML. In this case, we're going to get the cars element, which contains all of the information that we're going to need. It also contains some information we don't need, like Billy's cars, but we'll parse that out after we've accessed it. Once we've imported the right libraries, we can directly reference the concept of an XML element within our code using the element class. And we can create a new element object and assign its value to the root element of our XML document. Of course, we need to go deeper. The root level of our XML document is not directly useful to us. We need the information contained within it. We only really want the information from this owner node, but because of the way XML parsing works, it probably makes sense for us to first acquire both of these owner nodes and then find the one that we're really interested in. To acquire both of these nodes, we can call a method on the XML element we've just created, the root element of our XML document. XML elements can contain within them other elements. In this case, our root element contains a number of owner elements. The method getElementsByTagName allows us to collect a number of these inner elements. The tag name of an XML element is just what you would expect, the name we gave to this section of our XML. In this case, if we ask for all the elements with tag name owner contained within our document's root element, we're going to further narrow down the amount of XML we're working with, getting closer to the small section we desire. Now, we're no longer dealing with our root node at all. We only have its contents. What's returned by this method is not a single element, though. There's two distinct elements in this section, even at the highest level. Two owners, Billy and Jane. So, getElementsByTagName doesn't return a single element. Instead, it returns a node list object, which, believe it or not, is a collection of XML nodes. Now, it's time for us to really narrow down our search. Our node list contains multiple owners, but we only want an owner if the attribute name associated with that owner happens to be Jane. In order to find this particular element, if it exists, we're simply going to loop through our node list, checking the attributes of each element it contains. Owners list is not a traditional array. It's a node list, its own kind of object, so we can't use normal array syntax on it. Fortunately, it exposes methods to us that mimic normal array syntax. For example, the getLength method will tell us how many objects are in this owners list. Similarly, when we attempt to create a new element and assign that value to the currently looped through portion of owners list, we're not going to be able to use the normal syntax we would for an array. Once again, though, owners list provides us a method to do the same thing. The item method provides or asks for an index as input. Owners list, though, is a node list. While elements are nodes, not all nodes are elements. So we need to make a decision here. We could check the nature of the objects that are returned by this function and assure ourselves that they are in fact XML elements. But to keep things moving, we're just going to assume that our XML was properly formatted. And we're simply going to let Java know that the node returned by this method is in fact an element. It has a start tag and a closing tag and can contain other elements and nodes within it. Once we've successfully got an element from our list of owners, it's now time to check and see if this is the owner that we're looking for. So we're going to need a conditional statement. XML elements expose to us the getAttribute method. And the attribute that we're interested in is the name attribute. So this bit of code right here will ask the current owner, what is the value of your name attribute? If that value is equal to Jane, then we know we have accessed the right XML element. Within Jane's XML element, we now only have a number of car elements. So it's once again time to create a node list and populate it with these cars. Rather than using the top-level document, though, we now need to call this method on Jane, our current owner. If we were to use the top-level document, we would get all cars in the document, even, what was his name? Billy's. This main method is getting a little intense. This is about as far as I'm willing to go in one method. We're already a couple of levels deep in our code. And it's not exactly simple code we've been writing. I think it's time for us to parse out the next bit into its own method. Let's simply declare that we're going to have a method print cars. And this cars will take a node list of car elements to print. Now, leaving our main method, we'll declare our new cars list. Because we're in the static, or because we're in the entry class of our program, and this method is being called by the static main method, it should probably be a static class. And all it's going to do is print to our console, so void is an appropriate return type. We already know it's going to take a node list, cars, as input. Once we've entered this function, we know we have a list of car XML elements at our disposal. But in order to print each one out, we're going to have to loop through them. We've already looped through a list, a XML node list in our program already. So we're going to be using some very, very similar syntax. Here's our loop from earlier. Let's take a look at what needs to change for this new code. Well, we're no longer looping through owner's list. We have a new node list to loop through, the cars node list. We know that cars are still elements, so our casting shortcut here is still appropriate. But we probably want to rename the variable we're using for each car we loop through from owner to something like car. Each time we loop through a car, we're going to be creating a new car object and storing the information in that car's XML in this actual Java object. So, in addition to accessing the car XML, let's also declare a car object and just instantiate it to be a new car. Let's actually name our XML element representation of the car node, so that we don't get it confused with our car object. Now, we're going to build up the values stored within the car object by reading them from our car node. If we jump back to the XML quickly and take a look at the information stored in the car node, we'll see that it stores make, model, year, and color as XML nodes within the car element. The vehicle identification number is actually an attribute. Let's start with the easy pieces. Make, model, and color are all strings stored in the car class, and they all happen to be nodes within the car element. We already know how to access nodes within an element. We're simply going to use car node and then get elements by tag name again. If we get all the elements with the tag name of color, we should return a list that contains only a single element, the element we're interested in that tells us the color of our car. Unfortunately, we do have a list here, so we can't manipulate that element directly until we pull it from the list. Once again, though, we know how to do this. If we're confident that our XML is properly formatted, we know we've achieved a list with exactly one item in it. So if we get the item at the 0th index of that list, that will be the XML element that we're looking for. Color stored in this XML element, though, isn't an attribute. It's inner text. So we're going to need to take a look at what methods XML element exposes to us and see if there's an appropriate one to acquire that inner text. And there is. GetTextContent will give us all of the inner text that's not actually part of XML element tags. In this case, it's going to give us the color of our cars. We're going to do pretty much the exact same thing for make and model. The only thing we're going to have to change is the keyword we provide when looking for the elements. Now, it's not enough just to acquire this information, we need to store it. Fortunately, all of the attributes of our car object are public, so we can freely assign them values after we've created our car. If these were private fields without setters, we'd probably have to do this information before constructing our car object and then pass them through to a constructor that it would hopefully have. Now, we can continue using the same general strategy for our car's year. But we should note that as far as our car Java object is concerned, year is an integer. But as far as our XML element is concerned, year, just like anything else, is a text content string. Fortunately, converting a string to an integer, as long as it's well formed, which is an assumption that we'll make here, isn't too difficult. We're simply going to use the integer class and call its parseInt method, which will do its best to convert a string value to an integer. Oh, right. And we'll assign that to our car object's year field. That leaves only one more field for us. Car object has a vehicle identification number field. This field is not actually an integer. Vehicle identification numbers can contain letters, so this value is stored as a string. It's going to be a little different for us to get, though, because rather than being an inner element, it's actually an attribute of the car element itself. Once again, though, we know how to acquire an attribute from our car node. We're simply going to get the attribute with name Finn and assign that to our car object. With all of this done, our car object should be fully built with reasonable values in all of its members. Now, it's time to use the car object for the reason it exists, this overridden toString function. For each car we loop through, let's now call car objects toString function and print that result out to our console. Oops, looks like I've forgotten to give our method a name. I think we decided to call it print cars. And also, we're looking for year here, not model. Once we've made those changes, we should be good to compile our program. And now, hopefully when we run it, it's going to print out all of Jane's cars, making use of our Java car object's overridden toString method to nicely format the output. When we run this program, we get 2 cars printed as output. And if we go to our XML and take a look at the cars assigned to Jane, we'll see that this information does indeed match the information stored in these cars. The XML and Java combination is really powerful. XML is human readable. We can understand it and even make modifications to it as people. But it also contains really valuable information in terms of how it is structured that programming languages like Java can understand as well. The program we've written here, while it does have its quirks and knowledge we must have to write it, is much, much easier to write and far, far easier for a programmer to understand and maintain than a similar program reading from a raw text file would probably be. See you next time.